Thank you, Maria. I'll share my screen. I assume everybody can see my screen. Well, welcome to this session. My name is Finnur Bragason. I am the Global Sales Director at AGR. I've been working with the company now for over 14 years, introducing these best practice processes around forecasting, demand planning, order optimization, and these things. Now, today I'll be taking you through a couple of slides. I want to explain first the process that we'll be going through today. Then I want to go a little bit into the ROI calculations, just to understand why do we want to optimize our inventory levels and what is the potential financial gain from this process. The majority of the time I'll be spending within the AGR solution itself to show you how we do those day-to-day processes of creating forecasts, classifying the items, creating an ABC analysis, and eventually optimizing the inventory levels through automatic ordering. Now, if we begin with the high-level process that we'll be taking you through today, we assume that the main data registration resides within your ERP system, whether that is Dynamics Business Central or any other ERP system. This is where you have your product information, your sales information, and so forth. Now, the first step in the process to optimize the inventory levels is to create a statistical forecast. Now, the first step is then that we look through all of your sales information. We look at all of the transactions, and the system actually has what we call expert forecast model with multiple algorithms and forecasting methods built into the system. So if there is any trend in the data, the system will capture this automatically. So Easter, spring, summer, winter, any growing sales or decreasing sales, really if there's any trend, that will be captured automatically. I'll show you this a little bit later on, how this looks graphically and how we can apply the safety stock calculations. But as a high level, we use ABC analysis to categorize the items into the most important items, medium importance, and low importance. And then we can assign a target service level to those categories. So your A items would typically carry a high safety stock, 95 to 99%, and the system will then, according to the forecast accuracy, determine how much safety stock you need to carry. Now, of course, we can't trust an automatic forecasting system for all our items. This is where the exception reporting comes in. Generally speaking, we can trust the system for 80 up to 90% of the items, but we need to flag those items that we need to take a closer look at. So this is also in terms of prioritizing your work. You don't want to spend your time on those manual repetitive tasks. You want to spend your time on the more complicated items that need more attention, such as new items. With new items, we have no sales history and it can be difficult to forecast. In those cases, we have the option to connect sales history from an older item to a new item, and we can then borrow that sales history to kind of hit the ground running with those items. I'll take you through those scenarios and other exceptions within the system itself. Then it's the planning part. This is where the user can add his knowledge on top of the forecast. This could be knowledge for promotions, for example, or if some certain category is expected to increase significantly in sales, we can manipulate the forecast on any level of the business, whether it be on SKU level, vendor level, product group level, customer level, we can manipulate the forecast in those scenarios. The output then is either a transfer order from the warehouse to the store or a purchase order from external vendors into the warehouse. This is kind of a high level, the scenario I'll be taking you through within the system itself. But to begin with, I wanted to take a short ROI example of a company that has implemented a solution similar to AGR around forecasting and demand planning. Now, if we imagine a wholesale company, simple wholesale company, small to medium size, with $20 million in annual turnover, we assume that this wholesaler holds an average inventory value over the year of $4 million, thus having kind of a turnover, inventory turnover of 5. And the SKU size is roughly 10,000. Now, of course, we can scale these numbers up and down, but just this is just an example. Based on our 20+ years experience in the field, when a company introduces statistical forecasting with AI and machine learning, we have seen that on average, we are able to lower inventory levels by 15% on an annual basis. Now, of course, this is based on same service levels, because of course it's quite simple to reduce the inventory. You just simply buy less, but then of course you will have stockouts in place. But comparing statistical forecasting, for example, to min-max methods or average methods or simple algorithms that don't take into account that seasonality and those fluctuations in demand, this is what we're seeing on average. Now, if we take this further, we can see that the 15% stock reduction is freeing up a working capital, the value of $600,000 for this particular company. This is what the excess cash that we are getting out of the business. Now, we use 25% as an average cost of inventory holding. So this is both transportation costs, this is holding cost, warehousing, these are insurance, processing fees, and all of those fees that are associated with that stock. So we're estimated then an additional $150,000 savings on the cost of that inventory by introducing a system like this. Now, of course, this is just raw numbers that we're calculating on inventory reduction. Here we are not taking into account potential service level improvements, because if you have incorrect stock levels, we have too high stock on some items and too low stock on other items. So we're creating that balance in the inventory, so we can see actually at the same time as we reduce stock levels, we can increase service level. And on top of all of this, we can see there's a massive potential for reduction in manual work for those repetitive items. So giving the buyers more time to focus on these problematic areas. Now, with a project like this, we're typically looking at an ROI that can be calculated in months, and in many cases actually weeks, depending on how large the inventory is of the company that we are optimizing. Now, the components that we use to realize this is this statistical forecasting I'll take you through, the exception management. I want to focus a little bit today on the ABC analysis as well. And we have the demand planning part, promotion planning, and automatic ordering. So this is what I'm going to be taking you through in the system itself. We'll switch here to the online version here. So what you'll see here off the bat, this is a web-based solution. You simply log in through a browser, and I want to start here in my items card. So here I get a list of all of my items. We can see I have 1,423 items in this demo database. If I open up a random item here, the system will display graphically some of the parameters we're looking at. Now, if I put the mouse here, we see this is April 26th. So everything on the left-hand side here is historical data. And everything on the right-hand side, this is a forecast that the system automatically calculates based on the historical data. So you can see this is a very seasonal item, peaking here in November, December, and the system is expecting the same thing to happen here next year. Now, we can manipulate the forecast horizon and the historical periods. We can display the data on a daily level, on a weekly level, or monthly level. Now, if we move forward, here I'm selecting another item, item number 1. We can see here the system is not finding any trend, thus reverting to a moving average. But you're quite quick to see what is happening with the data. We can see here during a period in October and November, there are no sales. Now we can then add stock history as an overlay. So we can see when I make a purchase or purchase order is coming in, that the stock increases, and then we consume off of that stock. Now we can see here what happened is actually there were 0 sales, but that's because something failed in the purchasing and I didn't have any stock. Now in this case, the system can automatically detect these outliers, and we can create sales history automatically. We can also do this manually. So you can see here, once I create sales history, keep a look here at the forecast on the right-hand side, because the system will automatically update the forecast and create a better forecast moving forward. Now we can also take the sales history down. And here we can see that the system keeps the actual sales of 43 units, but uses the adjusted sales that I just adjusted of 18 units as a base for that forecast. Now, because I know my current stock level, I know what the demand is, we can also add here estimated stock as an overlay. So if we zoom in here, we can see that I will have a stock out for this item here May 31st if I do nothing. Now, we display the data graphically here underneath. On top, we have the numerical data. We have here the primary vendor, we have the product group level, we have some sales values, and we have this days cover on hand. So how many days in stock will this item last me? And we calculate that for all items. I can add here additional columns. I could have the ABC categorization. We can look at various sales data, and we can pull in. So basically all of the most important fields that you have in the ERP system, we can pull them in here and include them into the list and report on them. Now, when it comes to the safety stock calculation, because we can see here we have the safety stock, we displayed the safety stock for the order period. We need to take into account the volatility of the forecast. So I want to take an example here of an item that has a relatively stable sales history. You can see the forecast is around 140 units. And again, here we're looking at a moving average. Now, if I take an example of another item here, number 4, we can see the forecast here is around 140 units, similar to the other item, but we can see that the sales history is much more volatile. Now, when it comes to the safety stock calculation, the system looks at this volatility and it determines how accurate the statistical forecast is. Let me give you an example. We can see here that I have a confidence factor, which we can also call a target service level for this item is 80%. So that means we want to have 80% confidence that we'll have this item in stock. Now, if I manually change this to 98%, if you watch the safety stock line, you'll see it'll jump higher. Because of the uncertainty of this item, the system will prompt me to keep 60 units of safety stock to achieve this service level of 98%. Now, if we look at the previous item here, which had a more stable sales history, and if I do the same thing, you remember the other item, to reach a 98% service level, I needed 60 units in safety stock. But for this item here, I only need 23 units. So the system is constantly calculating the volatility, the accuracy of the forecast to optimize the safety stock levels to reach your confidence factor or target service level. Now, we do not go into every single item and set the confidence factor. In this case, we use an ABC analysis to categorize the items. Now, before I go into this, I want to just have a quick slide on the ABC analysis. I'm not sure if everybody is familiar with that. So this is a classification to determine what are our most important items. We can do the classification on turnover, we can do it on quantity, on margin, and on different levels. But in this case, I want to take the ABC classification based on turnover. So you can see here our A items. Those are 10% of the items that give us 80% of our turnover. So these are very important items. I want to have these items on stock no matter what. Now the second part is here are B items. These are the 20% of items that give us the additional 15% in turnover. So we can say combined A and B, these are 30% items that give us 95% of our turnover. And then we have the C category, and these are the majority of our items, the 70% of our items that give us only 5% of turnover. So in this case, I might not be as prone to keep those items at a high service level, so to say. Now, this is quite easy to display, but we have actually, within this solution, we have created an ABC calculator. So we can see here, there are some parameters here. We can have separate the ABC based on locations. We can separate them based on product group levels, but I'm just going to go with a simple ABC classification based on turnover, as we were explaining before. So in this case here, I'll get my A, B, and C levels, and I can then start to set the service levels based on those categorizations. And the system will recalculate the ABC on a regular basis, because items can move from one category to another. Now, as we say here, as I said before, we can do the turnover on multiple levels. We could do it on cost of goods sold, we can do it on margin, sales quantity, number of sales lines, but we could actually go a little bit further and we could do a twofold ABC analysis. So I could do it on cost of goods sold and on turnover, which gives me a little bit more in-depth analysis. Now this feeds into this importance categorization. So these are my high important items, medium important, and so forth. And this then again feeds into my dashboard when I log into the system to give me a bird's eye view of how my inventory is looking. So we can see here stock health, we can see active stock, new items, and dead stock. We can look at the forecast uncertainty. We can look at overstocked items. Here, for example, I'm looking at overstocked based on value, but I can actually go here and look at the item count as well. And again, here we can see items in risk of stockout. So these here I have 100 items that are classified as high importance and they are in risk of stockout. Now, if I go back to my items over here and I want to explain this last KPI, the risk of stockout. I just close this here. Here we had the different columns that we were looking at. Now, I have the column here, days cover, and I can actually filter on that column, and I can tell the system to give me only items that last me, say, 3 days or less in sale. You can see here the total database is 1400. Now we're filtering down, and now we can see we have 235 items that have only 3 days left of sale. Now I can further categorize this by taking any of these columns and dragging them up to the pane, and the system will group it. So we can see here in which categories these are. We see in accessories, I have 30 items in risk of stockout. Now I could then do a secondary filter and look at my primary vendor, and we could then go and look at accessories, and here we see the vendors. So I could actually click on here Nike and Bionic, and in this case I could create manually an order for these items from these vendors. Now what I could also do is I could filter down to a certain vendor and I could create a schedule. So I could tell the system that for a certain vendor, I want to order them twice a week, every Monday and Wednesday. Or we could go by a monthly order schedule where I'm ordering always on the 10th of each month, except for January because of Chinese New Year and August because I'm on holiday. Now the system will then go in and it'll look at the forecast, it'll look at the safety calculations, safety stock calculations, inventory levels, and all of the parameter, and it'll suggest an order quantity that lasts me from February 10th to March 10th. But here in July, the system recognizes I'm not placing an order in August, and it'll cover a longer period, a 60-day period. So when the user gets into work, he simply goes here into the orders pane, and the system has pre-calculated purchase orders for all of the items based on all of the order parameters from the ERP system and based on the forecast and service level settings that we have set forth. So here we can see we have multiple orders. If I click on an order here, say from FootJoy, the system will take me into that actual order, and we can see here we have the total rows. These are 500 units that I'm ordering. We can look at the stock levels. We can look at the estimated stock levels as well. Here we can see every time I order, the stock levels go up. And here we can actually look at this order. I can manipulate it in here manually. So if I decide to order, say, 10,000 units, the system will update the graph and give me a visual of how these 10,000 units will last me. So you can see here 1, 2, 3, 4, 5, and it becomes quite a visual. You can see if you're ordering too much and so forth. Now we can pull up additional information here. We can look at product information. Here we have aggregate numbers for the order. We have the total purchase value, total quantity, total weight, and so forward. And I can actually play with the columns I have included here as well. Maybe I don't want to see the ABC analysis. And I can take out some of the things I want to see. Maybe only see into what location I'm ordering. So we can play with this view, and we can create and save specific views for my orders. Now, I can also constrain these orders. So let's say I want to fit this order into a container. I would then highlight all of the items I have in this order, and I would create a constraint. So we can constrain on multiple parameters. We can do on cost value, days, number of pallets, purchase value, quantity, volume, and weight. So in this case, to constrain into a container, I would tell the system to be less or equal than 22 pallets. And then I need to fill up with my lightest items. Or we could do a value-based constraint. So here I would like to surpass that value. And I could say the cost value here, let's say if I go above 2.5 million, I'll get a discount. So we'll save that constraint. We'll go into our constraints here, and I'll apply the 2.5 million constraint. And the system then starts to iterate the order. It doesn't add proportionally to all of the items. It looks at the demand of each and every item and adjusts accordingly. And we can see here the total cost value is just above 2.5. Now, when I'm happy with this order, I can simply confirm it, and it will then be automatically transferred to our ERP system as an unconfirmed purchase order. Now, moving on to the reporting part, we have multiple standard reports in the system. So we typically arrange them by urgency. So you have your daily reports. So these are move in and move out lists. So these are purchase orders you might want to expedite if there is a shift in demand, or if there is no demand, you might want to move some of those POs out. We also have this review before stock out and urgent order required. So urgent, these are items that I need to, I'll have a stock out for these items if I do nothing. So if I go here, I look at some information on this report, we'll see here the formula. This is days on hand, so how many days of stock do I have, minus the supplier lead time, plus 3 days. So I have the supplier lead time plus 3 days to respond, otherwise I will have a stock out. And again, we can categorize this based on vendors, or can take the primary vendor up here. So we can play with this data in any way we want. Now on the weekly level, we can look at fast movers and slow movers, but we can also look at new items. This one is interesting because the new items, well, I don't have any sales history, so I don't have a forecast. So we can see we have 47 units here that are new with no sales history. Now in that case here, I can go into my connected items tab. And here I can connect an old item to a new item. So we have the new item, we select that from our list, we connect it to an old item. Now I can select to connect the stock separately. So if this is a superseding item, I still have 100 units of the old item on stock. So I want to take the combined stock levels of old and new into account when I'm creating that order. Now we can set the connection period, and we can also do some scaling here. So if I want to double the sales history, I can do that. There are multiple other reports in here. We've got some monthly reports on forecast accuracy, for example. We've got some analysis reports on ABCs, overstocked items, and so forth. It's quite easy. The user can go into these reports. We can manipulate the parameters. We have options to save the reports. We can share them with other users. We can share them with users or with certain roles, or I can keep this report as my private report as well. There's one thing I wanted to show you here in addition in the orders part, that's the order breakdown. Now, there are a lot of parameters that are at play when we are estimating the order quantity. So we're looking at forecasts, we're looking at service level settings, minimum order quantities, order multiples. You can be ordering into the warehouse in boxes, but sell it out in units. So it can, in some cases, be challenging for the user to understand why does the system come up with this number 2,940. In this case, we can go here into the info tab and we can see the order breakdown. So this means here we have a demand, there's a need for 1,478 items. On top of that, this is an A item with volatile sales history, so I'm going to need an additional 1,000 units in safety stock. I don't have any minimum levels, otherwise that would be on top. It's sometimes called display stock or something like that. Now I have 125 units in stock, so that means that the total calculated need is 2,369. Now we can then further go and look at if there are minimum order quantities. We will round up to that, and then we will have order multiples. So if I can order only in boxes of 10, for example, in this unit, the system would round up to 10. We can also look at the actual formula in here, how the system is actually deriving those numbers. And in this case, of course, I have applied a constraint, and that is why the system has increased the quantities to meet the minimum value constraint. Now, there's one other thing I wanted to show you here in the planning part. If we have set schedules for all of our vendors, we can calculate purchase plans into the future. So we know the order intervals, we know what we are going to order, we have a forecast for the year. So here I can select a vendor. I can select on the bottom right here, the period. Here I'm looking at the 12-month rolling period. And here I have a list of all of the items from this particular vendor. We have estimated future order date and future delivery date. So I can export this to Excel. I can share this with my vendor. It can be particularly interesting when we're doing price negotiations, or just for the vendor to be aware of what I'm going to be purchasing for production purposes. I could probably go on for another hour or so with all of the functionalities. This is a high-level overview. There's a lot of smaller functionalities and smaller options in here that we can solve. But in a nutshell, this is what the AGR solution does. And on top of that, we want to emphasize the point that we have an D365 Business Central and NAV API. So we can set this system up with minimal technical resources. It's just within a few hours. We offer this solution with Azure hosting and a simple implementation process that is mostly consists of just training and configuration with the users. And this is all included in just one monthly fee. So this means the data connector, the training, the configuration, services, and the hosting of the solution itself is all included in one monthly fee. So this means there's really no risk. You can actually try this out for a month or two. You can see if you like it. It works on your actual data. It has your actual stock levels, and it'll create actual purchase orders into your business, so you can understand the potential behind this solution. We have around 650 customers. The retention rate on this solution is quite high. So that means once implemented, our customers are usually quite happy and keep on using the solution. AGR has been growing quite fast in the last few years. We're over 80 employees that do only this. We don't have any other solutions. We just focus on this one solution, this one field forecasting, demand planning, and inventory optimization. Now that was all for me. Thank you very much for your time. I think we still have a few minutes left. If there are any questions, I would be happy to walk you through that and explain further if there are any questions.